How well do we know our exponents? Let's test our knowledge about exponents by answering this power challenge. Here is our problem for today. Find all real solutions to this equation. The quantity 2 minus x squared all raised to x squared minus 3 square root of 2 x plus 4 equals 1. The solutions are letter A, plus or minus 1, letter B, plus or minus 1 and square root of 2, letter C, plus or minus 1 and 2 square root of 2, and letter D, plus or minus 1, square root of 2, and 2 square root of 2. You can pause the video and see if you can answer this power challenge. Let's solve this problem together. In order to find the real solutions of this given power challenge, we need to recall that any number except 0 raised to 0 equals 1. For example, if I have 5 raised to 0, the value of 5 raised to 0 is equal to 1. If I have, let's say, 125,000 raised to 0, even if the number is big, 125,000, still the answer here is 1. Because any number except 0 raised to 0 is equal to 1. There is a problem if we have the form 0 raised to 0, because this will create some inconsistencies in mathematics. And many texts would suggest that we just leave 0 raised to 0 as undefined, while in the context of limit, there is a different interpretation for 0 raised to 0. But for our context here in arithmetic and algebra, we will avoid defining 0 raised to 0. So we will write 0 as an exception to this rule. And we are going to go back to this exception when we find the solutions of this problem later on. Also, let's take note that 1 raised to any exponent is equal to 1. For example, if I have 1 raised to 10, the answer is 1. If I have 1 raised to, let's say, 256, no matter how many times you multiply 1 by itself, still you will get the same answer, 1. So you can make the exponent any big number or small number, still 1 raised to any exponent, the result is 1. So therefore, we can use these two cases in order to solve our math challenge. Let's begin with case number 1. For case number 1, given that we have this equation, any number raised to 0 equals 1. That means, if you let this exponent be equal to 0, then no matter what is the value of this base, the quantity 2 minus x squared, if the exponent is 0, the value of this would always be equal to 1. So therefore, we can now equate this exponent x squared minus 3 square root of 2x plus 4, which is now this one, equal to 0. That means we are making this exponent equal to 0, and when that exponent is 0, then we know that the value of this left-hand side of the equation is equal to 1. So by letting this exponent be equal to 0, we need to find the value of x, or we need to find the roots of this equation. This is a quadratic equation that can be factored as the quantity x minus 2 times the quantity x minus 2 square root of 2. Then we equate to 0. To check, you can perform the FOIL method and you will go back to the original equation. One way to arrive at these roots would be to apply the quadratic formula, or you can use the new method we discussed in this page, which we call as the Po-Shen law method for solving quadratic equation. Since we now have this factored form of this quadratic equation, we can now solve for the value of x. And from the first factor, if we equate this to 0, we have x equals square root of 2, and for the second factor, we have x equals 2 square root of 2. So these are now the first two roots that we are going to consider for our math challenge. But later on, we are going to test whether these two roots satisfy all the conditions of the problem. But for now, let's remember we have these two possible roots, square root of 2 and 2 square root of 2. Now let's go to case number 2. We said that number 1 raised to any exponent equals 1. So this means if we can let the value of this base be equal to 1, if we can let this be equal to 1, then 1 raised to any number, no matter how big or small, would result to 1, which is the desired value of the equation. So therefore, let us now equate 2 minus x squared to 1. That means we want the base to be equal to 1. So solving now for x, we can add x squared to both sides of the equality and subtract 1 to arrive at this next line. And then simplify and get the square root of both sides. We have this value, x is plus or minus 1. So for now, it appears that we have 4 roots. You have square root of 2, 2 square root of 2, 1, and negative 1. So let's call these roots as x of 1, x of 2, x of 3, and x of 4. But there is a big but. Remember, there is no definite agreed upon value for 0 raised to 0. We do not know what's the value of 0 raised to 0. And in many texts, they said that the value of 0 raised to 0 is undefined. So that means we don't want this base to be equal to 0. Because if this is 0 and our exponent is 0, then we will arrive at this form which we do not define. We need to make sure that nothing among these 4 roots will make this base be equal to 0. We don't want the base to become 0. But notice that if x is equal to square root of 2, this becomes 2 minus, instead of x, we use square root of 2, and then we square. What is the value of this? So we copy the 2 minus, we can cancel out the exponent and the radical square root. So what is left is 2. And 2 minus 2 is 0. This means that if we accept x equals square root of 2, then our base would become 0. And since this exponent is 0 when we let x be equal to square root of 2, then there is a problem. And because of this problem, we are going to remove square root of 2 as a solution. And so we are left with these 3 roots. Using now these 3 roots, if you substitute that for x squared, you will no longer get 0 in the base. And when you use x equals positive 1 and x equals negative 1, that will make the base equal to 1. And 1 raised to any exponent, no matter how big or small, will make this equation true. So finally, our answers now are x of 1 equals 2 square root of 2, x of 2 equals 1, and x of 2 equals negative 1. So this problem might look complicated, but the concepts we used here are the same concepts we used when we are learning the basic of exponents. We just raised the bar a little bit to make this more of an analysis question that will hopefully help us become more mathematically mature by experiencing a lot of beautiful, hard math problems. So thank you very much, and we hope to see you again in our next video.